Part C. When P and Q collide, there are a distance d from a smooth fixed wall which is perpendicular to the direction of motion. After the collision, P and Q collide, so directly with the wall and rebound, so there's a second collision between P. This takes place at distance x from the wall, given that E is an 18th and the coefficient restitution between Q and the wall is a third. Find x in terms of d. Let's draw a picture. So here we've got P, which still weighs 3m, is travelling with the velocity we worked out somewhere earlier. There's W? No, V. This velocity, except now we know that E is an 18th. So if we were to stick an 18th into that, we've got 1 minus 15 times at 18th divided by 8 gives us 48th. So that's going U over 48. Remember, this is after the rebound, so they rebounded here somewhere, but after the rebound, Q is going with the velocity we worked it back here, so 9 times an 18th plus 1 equals, divided by 8, 3/16. Oops. It's 3 over 16 after the rebound, and then they're going to hit a wall over here. So they rebounded, they hit each other at this distance here. That distance is d away from the wall. And then after they hit each other, they're both still travelling that direction because the motion was unchanged, except now we know that E was an 18th, then that gives us the actual speeds in terms of U for all those ones there. And then that's going to then hit the wall. After the wall, the coefficient of restitution with the wall is a third. So after that, it's going to be travelling with a third of the speed. So U over 16th. But it's still going to be the same mass afterwards. So, and afterwards, that one is still travelling that direction. And then they're going to crash into each other here somewhere. Bang! And they're going to crash into each other here. And that distance they crash into each other is x from the wall. So that's the speed of P after the collision, which happened here. That's the speed of Q after the collision, which happened here. They're both going that way. That's going to be banged off the wall. It's then going to have that speed, and then they're going to bang into each other here-ish again. And we want to work out the total what are we trying to work out in this question? As I've forgotten. And we're trying to find x in terms of d. So we're trying to find out where this distance is at the collide again. Okay, we can work out the times. So firstly, we work out the total time for Q to hit the wall. We know that Q's, this is where the collision takes place. We know it's got to go d, and it's going that speed. So the time for Q to hit the wall is going to be equal to how far it's got to go divided by how fast it's going, which is equal to 16d over 3u. And then after Q hits the wall, Q then is going to bounce back and it's going to hit P. So time for Q to collide with P after rebound, it's got to go x, and it's going at U over 16. Which is going to be 16x over U seconds, probably. The third thing we can work out is how long it's going to take P to collide with Q after Q's rebound. So the time for P to collide with Q, P is going to go that distance, which is d minus x, divided by P speed, u over 48, which is going to be 48 d minus x over u. So, altogether, after the collision, Q's gone all the way down there and bounced back to there, and the total time for Q is equal to the time it took to get to the wall plus the time it took to collide with Q. The total time for P, well, in all the time that Q's done all of that, P's managed to go to there, and it took P that much time to do that. However, these times must be the same. However long it took Q to do that, it took P the same time to do that, because they're in the same place at the same time. So, therefore, we can therefore say that 16d over 3u plus 16x over u, the time that it took P to get to the collision, is equal to 48d minus x over u, which is the time it took Q to get to the collision. If we then times that by 3u, we'll get 16d plus 48x is 144d minus 144x, which simplifies to be 182x is equal to 128d, which simplifies to be 128d over 192, which works out to be 2d over 3. 2d over 3 is the distance from the wall in terms of d where P and Q collide for the second time.